All right, so we're going to look at the basics of geometry. What do we define geometry to be? So we're going to start with some basic terms. A geometric point is defined to have zero size, so a little dot there. It's got no length or width, it's just a single point in space. A geometric line is formed by connecting 2 points along the shortest possible path. So if we take 2 points and draw a line between them, or the object we draw between them is considered to be a line. Line segments are pieces of a line. So inside the line itself, you have this itty bitty spot right there, and we call that a line segment. A geometric plane is a perfectly flat surface that has infinite length and width but no thickness. We might describe that sort of looks like a piece of paper, but it goes in either direction. Okay, the dimension of an object can be thought of as the number of independent directions in which you can move if you were on the object. So if thinking about a point can go up or down or left or right. And if we add multiple directions, so 2 dimensions versus 3 dimensions, we get different types of objects. We can also think about dimension by the number of coordinates needed to locate a point. Okay. The intersection of 2 lines or line segments forms an angle. So here we got 2 lines that intersect, and that piece in between we refer to as an angle. The point of intersection we refer to as the vertex of the angle. Angles themselves come in 4 main varieties. We have a right angle, which simply means it's a 90 degrees, and we use a box symbol to indicate that it's a right angle. We have a straight angle, so I don't want to do that. Straight angles are 180 degrees. We have an acute angle. So we look at right, an acute angle is anything that's less than 90. And we have an obtuse angle. So again, if we think about a right angle, then an obtuse angle is anything greater than 90. But in the same sense, less than 180. Okay, find the degree measure of angles that subtend or span. Subtend, if you think about in a circle, here's the center. When the endpoints of those segments connect with the circle, that arc of the circle that we see, that's the subtend, or another way to say span. Okay, so let's start with a semicircle. Semicircle is half of a circle. So if a circle itself consists of 360 degrees, then half of 360 would be 180 degrees. So a semicircle has 180. A quarter of a circle, so 1/4 of the 360, would count as 90 degrees. An eighth of a circle, so 1/8 of 360. 360 divided by 8 is another way to think about it. It's 45 degrees. And 100th of a circle, so 1 over 100 times 360 is equal to 3.6 degrees. Okay, a few more terms. Plane geometry is the geometry of two-dimensional objects. So all the objects we just looked at were one-dimensional. We're going to break it up into 2D objects. All right, starting with a circle. So in a circle we have a center. From the center to one of the sides, we call it a radius. Radius. And if we go all the way across the circle, we call that a diameter. A polygon is any closed shape in the plane made from straight line segments. So anytime I can connect line segments together and form a different shape, so things like a triangle or maybe a parallelogram would be different examples of polygons. A regular polygon is a polygon in which all the sides have all the same lengths and all the angles, all the interior angles are also the same. So we might think of that as an equilateral triangle where all three angles have the same angle and all three sides are the same. And the way we mark those, by the way, those little tick marks on the sides, those indicate that the segments are the same. And the angle marks, the arc marks, communicate that the angles are actually the same as well. All right, triangles are one of the most important polygons. They do take on different forms. So we have an equilateral triangle, which is the one that I was showing earlier. All three sides and all three angles the same. We have an isosceles triangle. An isosceles triangle, we only know that two of the sides are the same. So we don't know anything about the third side. But we refer to that as an isosceles triangle. We have something called a right triangle, which is when there is a right angle involved. One of the nice things about triangles is that all the angles, all the internal angles, add up to 180. All internal angles sum to 180 degrees. All right, the perimeter is the length around the boundary of an object. If we talk about the perimeter of a circle, we actually refer to that as circumference. Okay, area is the amount of space inside an object. So one measure you'll hear it used is called square units. So if you think about it, a square unit is literally a square that's got length and width of 1. So when we talk about how many square units fit inside an object, we're literally asking how many squares of unit length 1 and width 1 would fit inside this object. Okay, Some common formulas that would be worth knowing or getting to know. Let's start with circle. So the perimeter formula for a circle is the same as the circumference formula. So circumference is 2 pi times the diameter. And the area formula for a circle is pi r squared. Then we have a square. And so the perimeter for it is 4 times the side length. And the area formula for it is just length squared, length times width, but when they're both the same, then we can just square them. Alright, then we have a rectangle. We have perimeter is 2L plus 2W, and area is just length times width. We have something called a parallelogram. So the perimeter is kind of the same as the rectangle, 2L plus 2W. And it's also length times width. The difference between the two objects, rectangles have right angles in them and parallelograms don't. And then we have a triangle, which is, for perimeter, we're going to add up all 3 sides. Now area is going to be 1/2 base times height. Note, base and height form a right angle. So whenever we're looking at a picture of a triangle, we would use that to calculate what the area of the triangle